Okay, so what we're going to do here is an exponential growth problem where you have a bacteria that is going to duplicate every 15 minutes. So you start with one single Salmonella bacterium, and after 15 minutes you'd have two, after a half hour you'd have four, 45 minutes you'd have eight, and so on and so forth. Alright, so what we want to do is basically use Excel to help us figure out how much bacteria would be in the cup after 2, 6, 12, and 24 hours. Then we're going to graph all this and put it in Excel. So let me kind of show you some nice strategies here. So once we get Excel opened up, we're going to want to make a table. We could say time and bacteria. Bacteria. Alright, and so we kind of have two different things we're looking at. We have the initial time where there's one bacteria, and then T is 1, T is 2, 3, 4, and so forth. Now, what makes this one interesting, let me center this, is that this is not like 1 hour, 2 hours, 3 hours, 4 hours. This is every time increment. So this is basically initial time. This is 15 minutes. This is 30 minutes. That's 45 minutes. That's an hour. So just as a note here, 4 is 1 hour. That means that 8 would be 2 hours, and so forth. So you kind of have to keep that in mind when you're comparing things like that. Alright, and then if we're doubling, our formula is equal to initial amount times growth factor raised to the t. Right, so there's our formula for exponential growth when you're doubling. Then I can kind of take that and copy it down to here. Right, we can see that as doubling. Now, we want to go up to 24 hours. So looking at 24 hours, every 4 time units is an hour because there's 4 quarters of an hour and an hour. If we want to get to 24 hours, we're going to have to basically take that times 4. Another way to think of it is whatever t is, if you divide that by 4, you get how many hours it's been. Okay, so you can kind of do something. Let's get rid of this. We could kind of insert another column here just for fun. This could be maybe like the actual time, and that's going to equal this divided by 4. So then we can see, 1 time unit is 15 minutes, 2 time units is half an hour, and so forth. So we're going to have to go down pretty far. Let's jump way to there and see what that looks like. And I can take this here and drag that one down. And we can see, 24 hours then would be right here, 96, time units, so 96 set of 15 minutes. Alright, so now we have, this isn't really part of our graph, it's just there to be helpful. This is the time we actually plug in. This is the t that gets plugged into the equation. Alright, we can kind of copy this one down too. There we go. We obviously got some big numbers here. Now you'll notice that at this point it starts hitting scientific notation. We could probably fix that if we wanted to. There you go, hit number, then that, puts it in standard form. Okay, so we can definitely see these zeros are irritating me. I don't like the 0.00, so I'm going to go format cells and number. I'm going to say I want 0 decimal places. Okay, good. Thank goodness. Alright, so once we have this, we can kind of look over here, and it says, show the number of bacteria, use Excel to graph it, so we can graph that. When will it reach 1 million? Well, we can kind of look here and see when it's going to reach 1 million. Remember, if you say, 17 is the answer, that's actually 4 hours and 15 minutes, so make sure that you kind of refer to that one. Now, when it says the graph, we can highlight all this stuff, and we're going to insert scatter plot. Alright, now the problem with that, oh my goodness, I don't know what the heck they did over here. Yeah, if you look at it, because it gets so big so fast, your y-axis is just insane. And you can't really even see anything other than the end of it. So I probably wouldn't graph the whole thing. What I might do is maybe only graph, up to like 5 hours or something. And so you can kind of pick and choose how much you graph. If you graph all the data points for 24 hours, it's going to look really crappy. So, because it just starts growing so fast. So even here, you can see slow, and it kind of shoots off. So maybe we can even make that a little bit less. Maybe just do the first 4 hours, or even the first 3 hours. But you can definitely see no matter which how much data you graph, you're going to get that nice exponential curve in there. Yeah, so now what we really want to do once we have all that is we want to write an equation. Well, we technically already have an equation because we used it over here to do that. But if I go on to here and go to add a trend line, obviously a linear trend line does not look good at all. But if we do an exponential trend line, then we can see it's definitely much better. Now, unfortunately, it uses this natural logarithm thing, so that's actually probably not what we want. It would have been nice if it gave us the one that we want. So let's go ahead and just kind of write ours out. Y equals, or A equals, do that. And then what would that equation be? You can type that out there. Okay, so unfortunately, this is not really the exponential we want. It ends up being the same thing because we actually typed the equation in here. Notice how we have a perfect fit. Every point's going to be on that line. So let's write the equation out the way we did it in class. Basically, that's kind of the first part of all this. The next thing, we're going to change how often the bacteria doubles. Now it's every 5 minutes. Okay, so that's going to kind of change a little bit here. So now, instead of doubling 4 times an hour, it's basically going to double 12 times an hour. So that means that this would have to be divided by 12. 5 goes into 60 12 times. Yep. And so now if we kind of look at this, let's pull this down real quick. So now if we look at that, every unit of 1 here is actually 5 minutes here. So every 12 times, that's going to be an hour. Because there are 12 5 minutes in an hour. And so you'll notice that basically it just makes things go a lot quicker, double a lot faster. If I want to get to 24 hours, then I'm going to have to take these and go a lot further. Okay, so I'll have to take that one here. Let's see how far that I have to get over. It's still not 24 hours yet, so you have to kind of expand all that out. And when you drag these, you're going to get some pretty intense numbers. It might be nice maybe just to use some scientific notation in that case. So it could be a little intense. Alright, so basically what you're doing is you're going to answer A, B, and C, then you're going to answer A, B, and C again with question D. Then you're going to answer some stuff on here. So since to do an Excel and a Word document, I probably wouldn't do that. The best way to answer these, once you have all this stuff on here, is just insert a text box. So somewhere in here, go to Insert, Text Box, and then just kind of put all your answers in this box so everything's kind of neat and organized. Alright, so it's a pretty fun assignment. I think you'll enjoy it.